XML looks simple until you hit namespaces, attributes, SOAP envelopes, and unpredictable structures. In real enterprise integrations, XML is everywhere: ERPs, SOAP services, legacy systems, and B2B partners. In this video, we'll walk through 5 real DataWeave scripts that show how to read, transform, normalize, and safely handle XML and SOAP responses the way it's done in production. Let's get started. Script 1. XML output, wildcards attributes. We begin with script 1, where the goal is to generate XML output while navigating existing XML using both strict paths and wildcard selectors. We start with %DW2 0 and specify output application/XML, which tells DataWeave to render objects as XML elements. By defining an employee's object at the root, DataWeave automatically creates an employee's root element. In option 1, we access payload, employee directly. This works when the XML structure is predictable. In option 2, we use a wildcard selector, employee. This is safer in real integrations because XML structures often change or include additional nodes. We then create static employee data, which DataWeave converts into repeated employee elements automatically. Finally, we extract email addresses using deep wildcards and map over each employee, reading both the element value and the primary attribute. It's important to have safe versus unsafe casting in DataWeave. Let's look at these two lines. They look almost identical, but they behave very differently at runtime. In the first example, we read the primary attribute from the email element and cast it directly to a boolean. This works only if the attribute exists and has a value like true or false. But if the attribute is missing, DataWeave gets a null value, and casting null to boolean causes a runtime error. Now let's look at the safer version. Here we use the default keyword before casting. If the primary attribute is missing, DataWeave automatically uses false instead. Only after that do we cast the value to a boolean. This small change makes a big difference. The first line is risky in real-world XML. The second line is production safe. When working with XML or SOAP responses, always assume optional attributes can be missing. Default first, cast second. This script demonstrates XML generation, wildcard navigation, array handling, and attribute extraction, all in one place. Script 2. SOAP namespaces structured XML output next. Script 2 introduces SOAP namespaces, which are unavoidable in enterprise systems. We declare 2 namespaces, one for the SOAP envelope and one for the business domain, in this case orders. Using the prefix passed element notation, we create a namespaced root element called order. We safely extract a discount value using the default keyword, which protects us from missing optional fields. Then we navigate deep into the SOAP envelope, body, create order to extract the order ID and order mode. This script shows how DataWeave cleanly separates SOAP infrastructure from business data, producing a clean, contract-compliant XML output. Script 3. XML to JSON with attributes. In script 3, we switch gears and convert XML into REST-friendly JSON. Here, we extract employee metadata stored as XML attributes using the @notation. We read simple child elements like name using dot notation. Then we map over repeating email elements using the $sign to reference the current node. Inside the map, we extract the email value and explicitly cast the primary attribute to a boolean. This is a very common normalization pattern when exposing legacy XML data through modern APIs. Script 4. Complex invoice XML line items. Script 4 handles a more complex real-world structure, an invoice with nested line items. We start by reading the invoice number from an XML attribute. Customer data is extracted from predictable nested elements. For line items, we use deep wildcard selectors to safely locate line elements, even if the XML structure changes. We map over each line to extract SKU, quantity, price, and currency attributes. This pattern is extremely common when integrating with ERP systems like SAP or Oracle. Script 5. SOAP fault detection error normalization. Finally, script 5 handles one of the most important but often missed scenarios: SOAP faults. SOAP services frequently return HTTP 200 even when a business error occurs. So instead of checking the status code, we check for the existence of SOAP, fault using the question mark operator. If a fault exists, we normalize it into a clean JSON error structure, safely handling optional fields like detail. If no fault exists, we return only the SOAP body, stripping away the envelope entirely. This ensures REST consumers never see SOAP-specific structures. Let's recap what we covered. We generated XML dynamically, navigated unpredictable structures using wildcards, handled attributes correctly, worked with namespaces, transformed complex invoice data, and safely normalized SOAP faults. These aren't toy examples. This is exactly how XML and SOAP are handled in real enterprise integrations. If you can master these patterns, you can confidently work with any legacy or SOAP-based system. In the next lesson, we'll continue building on this and transform even more complex structures. If you're enjoying the series, make sure you like the video, subscribe, and check the playlist for previous days.